All right, welcome back. So last lesson, we learned how to add and subtract real numbers. This time we're multiplying and dividing real numbers. I was trying to think of some theme for this video. I just thought, man, let's rock out. So I found this page, people holding slugs doing guitar solos. I thought it was funny. I put it in. All right, moving on. So first up is multiplying real numbers, multiplying integers. You're going to have to write this in to your folder. And by folder, I mean your packet. So first we have 3 times 5. We all know that's 15. I bring this up because this is a positive times a positive. Over here we have negative 3 times negative 5. That's also going to be 15. The rule for multiplying integers, when you have 2 positives or 2 negatives, the answer is going to be a positive number. So if the signs are the same, these are both positive, both negative, it will be a positive number. Over here, 3 times negative 5, that's negative 15. Negative 3 times negative 5 is also negative 15. So if you have different signs, your answer will be negative. So that is a trick to doing multiplication with positive and negative numbers. When we're multiplying rational numbers, the same positive and negative rules apply, but we need to pay attention to what type of number we're multiplying. Over here we have 7.4 times 2.5. The first thing I know is this is going to be a negative answer because we have one positive and one negative, so that those are different signs. What I'm going to do is put it in my calculator, see what we get. Oh, man, I did it again. All right, so I put in 7.4 parentheses 2.5, parentheses negative 2.5, and I get negative 18.5. So my answer is negative 18.5. What I often see people do in their calculators, and this is a mistake, is if you want to multiply and you write 7.4 times negative 2.5. If you do that in the calculators we have in class, it's going to not think about the multiply and is only going to do a subtraction problem. So you don't want to do it like that. That's a mistake. All right, I'm going to erase that. When we have fractions like this, when you multiply, you do the top, the numerator, times this top, the other numerator, and the denominator times the denominator. First thing I do before I do that is think about the negative and positive. This is a negative, that's positive, so my answer is going to be negative. So let's do the math right now. 2 times 3 is 6. 5 times 4 is 20. So my answer is negative 6 over 20. I can simplify. I know these are both even numbers, so if I divide 6 by 2, I get 3. If I divide 20 by 2, I get 10, and that is also negative. All right, over here, this is very similar. Negative 4/5 times 4. 4 is a rational number. That's the same as 4 over 1. So if I multiply this, 4 times 4 is 16. 5 times 1 is 5. And it was a negative times a positive, so that's going to be negative. So that answer is negative 16 over 5. We're going to keep moving right along. So this case we have some examples. They might look a little scary, but they're not. We got this. So the first one, we have a mixed number multiplied by a fraction. You want to change the mixed number to an improper fraction. So to do that, first I know that it's negative. So I'll put the negative out there. Then I do 4 times 1 is 4, plus 3 is 7. And I keep the denominator the same. So I have negative 7/4 times 4 over 3. If I multiply this across, it's a negative times a negative, so that's going to be a positive. 7 times 4 is 28. 4 times 3 is 12. I can simplify, these are both even numbers, so I can divide by 2. 28 divided by 2 is 14. 12 divided by 2 is 6. These are also both even again, so 14 divided by 2 is 7. 6 divided by 2 is 3. So my answer is 7/3. Some people like to do this problem by canceling out the fourth beforehand. So we had -7/4 times -4/7. If you see this 4 and that 4, one on the bottom, one on the top, you can, this 7 should have been a 3. You can cancel those out. So if I multiply -7 times -1 is 7. 1 times 3 is 3. Either way works. If you don't feel comfortable canceling these out, you can do it the old-fashioned way and simplify. Now we have one with the absolute value bars. These are great. So what we want to keep in mind is GEMDAS, right? G for grouping symbols. We need to do the absolute value brackets, everything inside those first. So we have 3 times -8. That's going to be -24. The absolute value of -24 is +24. So that's your answer right there. The next one, we have a radical or a square root. That is also a grouping symbol, so we need to do everything inside here first. 3 times 12, that is 36, so we have the square root of 36, and that is going to equal 6. And just a reminder, a square root, that is a number multiplied by itself equals the number in there. So 6 times 6 is 36. All right, let's talk about some properties now. So the commutative property of multiplication means what? So with addition, it meant that you can move things around. And if you remember the word commute in a car, you're moving around. So this says that you can change the order of a multiplication problem and you get the same answer. So let's see if that works. We have 3 times 2. That's the same as 2 times 3. Well, they both equal 6, right? So this one works. You can also say 4x, is that the same as x4? Yes, it's the same thing. So commutative property in a car, commuting, you're moving. You can move the numbers around and get the same thing. What about the associative property of multiplication? If you remember from the example, right, your groups, I am friends with all these cats. These are my good buddies. So if I can reorganize in a group these multiplication numbers, will I get the same answer? Well, let's try. So if I group together 2 times 3 times 4, would that be the same as 2 times 3 times 4? Well, let's find out. So 2 times 3 is 6 times 4. That equals 24. Over here, 3 times 4 is 12. 2 times 12 is 24. So you get the same answer too. So the associative property and the commutative property you can both do in multiplication as well as addition. All right, let's talk some division. So the same rules are going to apply for if you have 2 positives or 2 negatives, your answer will be positive. If you have 1 positive and 1 negative, your answer will be negative. So 8 divided by 2, that's 4. 8 divided by -2, and this is a positive and that's a negative, so this will be -4. You can use this division symbol, or you'll see it more commonly with this fraction bar. 8 divided by 2 and it's negative, that's also going to be -4. You can see this written actually 3 ways. So this is one way to write it. This is the same as saying -8/2, and that's the same as saying 8/2. So these 3 things are the same, and you'll always get -4 with that. This one, you have 2 negatives, so that's going to be a positive. Remember, the same sign gives you a positive number. So -8 divided by -2 gives you 4. Let's do some rational numbers now. So 12.4 divided by -3.5. When you have a decimal like this, I mean, just stick it right in the calculator. I don't want to mess around long division with these decimals, so I just type it right in. 12.4 divided by parenthesis negative 3.5. What do I get? Ooh, that's an ugly number. Negative 3.542877. I'm going to round that to the nearest thousandths. So 3.543. Negative 3.543. Negative 3.543. So always, right, if you got a number like this, you got calculators, right, put them right in the calculator. This is one of the most important rules. It can be a little tricky sometimes. When you're dividing two fractions, what you're really doing is taking the first fraction, negative 2/9, and instead of dividing it by the second one, you multiply it by this one flipped. All right, so instead of 4/9, 9/4. So you flip it and then multiply. Flip, multiply. One more time, flip, multiply. All right, so this is going to equal negative 2 times 9, right? My answer will be negative. That 2 times 9 is 18. 9 times 4 is 36. To simplify, I know they're both even. They can be divided by 2. So I have negative 9 over what's 36 divided by 2. That's 18. I know these can both be divided by 9. So that will be 1/2, and that is a negative. So negative 1/2 is your answer. Over here, same thing, but they're both negative. So I write negative 3/5, and it's going to be multiply. So times negative 3/2. All right, negative times a negative will be positive. 3 times 3 is 9. 5 times 2 is 10. 9/10. Perfect. All right. And right, am I going a little fast for you? That's okay. You can just pause it. Take your time. Over here, we have a mixed number divided by 4. So let me change this to an improper fraction. 4 times 2 is 8, plus 3, that's 11/4. And you remember 4, that is a fraction. That can be 4/1. So I change that to multiplied by 1/4. 11 times 1, 11. 4 times 4, 16. Over here, we have absolute value. I just like to keep throwing in the GEMDAS, right? G for grouping symbols. 21 divided by 7, that was going to be 3. It's negative. So the absolute value of negative 3, that is going to be 3. We have a radical over here, so we do the inside first. 27 divided by 3, that is 9. So we have the square root of 9, and that equals 3. All right, what I want you to do now is pause this video, try these, and then check my answers, see if you got them right. So go ahead, pause that video now. All right, so what I did was stick this one in the calculator. But it's important to note it's a negative divided by a negative, so that will give you a positive answer. I also rounded this one, so if you got a different last one, this last number here, I got 2 because I rounded. Over here, 5/4 divided by negative 5/6, you need to flip this fraction and then multiply. So 5 times 6 is 30, 4 times 5 is 20. We have one negative, so it's going to be a negative. This can simplify. You see zeros right there. You can really just cross those out. Negative 3/2. This one, the absolute value, you need to do inside the absolute value bars first. When it's division, you need to flip the second number. It's 3/1. So I made it 1/3. I multiply negative 4 times 1, negative 4. 7 times 3, 21. The absolute value of negative 4/21 is positive 4/21. So let's check if the commutative and associative properties work for division. So if you remember the commutative, that's you can change around the order in multiplication. If we did 8 times 2, that's the same as 2 times 8, right? This 16. equals 16. That's good. I do a little happy face. So let's see, if I do division, will it be the same? So I can do 8 divided by 2. Does that equal 2 divided by 8? So 8 divided by 2 is going to be 4. 2 divided by 8, that is going to be 1/4. So these are not equal. This is sad. No, this does not work. Commutative, no. What about the associative? If you remember, that's when you make groups and you can change the groups around. So for multiplication, it was an example, 8 times 2 times 4. If I make this a group, is that the same as 8 times 2 times 4? I do that first. 16 times 4 over here. That's going to be 8 times 8. Right, this is 64, and this equals 64. So this one, that's good. Give that one a nice happy face. I'll give that one a nose too, and even a little tongue sticking out. But does that work for division? All right, so let me try it like this. I'm going to 8 divided by 4 divided by 2. And you know what? I'm going to write this down a little bit lower, give myself some extra room. 8 divided by 4 divided by 2. All right, I'll group that. On this side, 8 divided by 4 divided by 2. So I need to do the grouping symbols first. 8 divided by 4, that's 2 divided by 2, and that's going to equal 1. Over here, I need to do this first. 4 divided by 2, that's 2. And I have 8 divided by 2, and that's going to be 4. So these are not equal. This makes me sad. So do the commutative and associative properties work for division? No, 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 no. This is bad. Sad. Okay, moving on. What we're going to do now is look at some of these big fractions. Don't be scared. Keep that growth mindset. I know they look a little scary, but we can just break them into 2 smaller ones to make it a little bit easier. So we have 8x divided by 12, or 8x minus 12 divided by 4. This is the same as 8x divided by 4 minus 12 divided by 4. We can simplify these down. So 8x divided by 4, 4 can go into 8 2 times, and it can go into 4 once. So this simplifies to 2x. 12 divided by 4, that's going to be 3. So this answer can be simplified to 2x minus 3. And this will be really important for the next chapter when we start graphing and solving equations. So keep this in mind as we move forward. This one over here, 2x plus 9 divided by 3. Again, break it into 2 smaller fractions. 2x divided by 3 plus 9 divided by 3. You could leave your answer like this, but when we graph lines, we want to break the fraction away from the x. So I'm going to write this like this. 2 over 3x. And again, these are the same things, but as we go forward, you need to write it like this. And then we have 9 divided by 3. Well, 9 divided by 3 is 3. So our answer is 2 over 3x plus 3. The last one we have, 8 plus x divided by 6. One more time, we're going to break it into 2 fractions. So 8 over 6 plus x over 6. Can this be simplified? Yes, they're both even numbers, so they can be divided by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. Over here, when you just have x on the top, there's really a 1 in front of it. People in math are lazy. We don't like to write 1s. But if you see a number or a variable without a number in the front, it's going to be 1. So this will simplify to 1/6 x. All right, so that's the answer for that one. Keep this growth mindset. Make that a nice happy face. We want happy brains. This can be you. Growth mindset. All right, I'm going to leave you because we started rocking out at the beginning. I'm going to rock out at the end with a math, not a math video, with a rock video. All right, Darkus out.
Anything.
You gotta keep them separated.
Is the defending world champion. 5.8, 5.9, 5.8, 5.8, 5.7.